Hello and welcome back to Section 2. This is Unit 9 in Geometry, and we're going to talk about circumference and arc length. And so we're going to solve problems involving circumference of a circle, determine the radian measure of a central angle. That's a new thing. We're going to solve problems involving arc lengths, either in degrees or radians. So the first thing I want to do is talk about the circumference of the circle. So the circumference of a circle, remember that circumference is the distance around a circle, okay? Distance around a circle, okay? And the way we do that, we have this formula. Is C is equal to 2 times pi times your radius. Okay, now you can also do C equals pi times diameter. And the reason is because the diameter is equal to 2 times the radius. All right, so over in this picture, you notice that there is a radius here on this circle. But if I were to come over here and draw in a diameter, okay, draw this length in like that, okay, from that endpoint to that endpoint, what I notice is that I have 2 of these r's. Okay, so this whole thing is the diameter, but it's separated into 2 different radiuses. Okay, so that's how we get those formulas. Okay, and I would recommend either leaving these in terms of pi, okay, leaving pi in your answer, or using the pi button on your calculator. Okay, so let's go ahead and apply this circumference. Okay, it says that Mark commutes to work on his bicycle, which has tires that measure 26 inches in diameter. A device on his bike informs him that one tire completed 388 full rotations between the time he left the house and the time he arrived at work. Round to the nearest inch, how far did Mark bike between his house and work? Okay, so we're going to do this in inches. So what I know is that our circumference is equal to pi times the diameter. Okay, now the diameter in this case is equal to 26 inches. Okay, so now I'm going to do this. I'm going to find the circumference. Okay, and so my circumference is going to be equal to 26 inches times pi. Okay, and this gives me a value. Okay, and this is approximately 26 times pi is about 81.68 inches. So this is approximately 81.68 inches. Okay, and what this represents is this represents 1 revolution. Okay, 1 revolution around. So once, if your bike goes 1 revolution, all right, then that means that you have traveled 81.68 inches, provided that your diameter is 26 inches. So what I want to do is take this number here and multiply it by 388 full rotations, okay, because that's how many rotations we had. So if I take my circumference, so if I were to find my distance, okay, the distance traveled, then that means I would take my circumference, which is 26 times pi, and I would multiply that number by 388. Okay, so I'm going to do that. I'm going to do 26 times pi times 388, and that's going to give me 31,000. Okay, 31,692. Okay, and that's inches traveled, and that's what we're looking for. Okay, let's move on to the next concept, which is a concept called arc length. Now, it says that arc length S is a portion of the circumference of the circle. So what we're going to do in this is we're going to find the distance here between A and B that's along this circle, and we're going to call that S. Okay, so S is usually denoted as the arc length. Okay, now, first of all, before we do anything, let's find the circumference of the circle. Okay, I know that my radius is equal to 5, okay, and I got that here. And I know that my circumference is equal to 2 times pi times the radius. So circumference is equal to 2 times pi times 5. Okay, 2 times 5 is going to give me 10. So I get 10 times pi. Okay, and we're just going to go ahead and leave it like that. Your circumference would be approximately 31.4, okay, if we were to calculate the actual value. Okay, but I want to show you this. I want to show you that in this circle, okay, last section we talked about arc measure and how the arc measure, and this is different than arc length. Arc measure had you figure out what basically had you measured this arc in terms of an angle measure in degrees. Okay, now what I know is that this circle here, or this arc, has a central angle of 90 degrees, okay? And so what I'm going to do is think about this, and I say, okay, if this is part of a circle, okay, part of the, the edge of a circle, and this is a 90-degree angle here, then I know that this is a 90-degree angle that's a part of a whole circle, which is 360 degrees. So to find my arc length S, okay, what we're going to do is we're going to take a fraction of our circle and multiply it by the circumference. So what I know is that my central angle here is 90 degrees, okay, divided by 360 degrees. Okay, and I'm going to multiply that by the circumference, which is 2 times pi times your radius, which is 5. Okay, so let's kind of simplify this. Now, what I know is that 90 over 360 can simplify to 1/4. So I've got 1/4 times 2 times 5, which is 10, times pi. So my arc length here is going to end up being 10 times pi divided by 4. Okay, so let's go ahead and do that real quick and plug that into the calculator. I'm going to do 10 times pi, and then I'm going to divide that by 4, and that's going to give me an arc length of approximately 7.85 units, okay? And that's how long that arc length is. All right, so let's kind of think of a formula here, okay? The formula that we can use for this is our arc length S is equal to whatever your central angle is, theta, okay, divided by 360 degrees times your circumference, which is 2 times pi times your radius. Okay, now let's kind of clean this up a little bit. I'm going to do this all as one fraction. I'm going to do theta times 2 times pi times your radius all over 360 degrees. Okay, I'm going to use that for my formula for arc length. Okay, so now over here, let's kind of apply this problem here. Now what I know is that if theta is equal to 15 degrees, what is the length of AB? So we want to find this arc length between A and B. All right, now my radius is equal to 7. Okay, R is equal to 7, and theta equals 15. Okay, so I got that value here too. All right, so using my formula for S, my arc length S here, okay, that's going to be theta times 2 times pi times your radius, all divided by 360 degrees. Okay, so let's plug our values in. So I've got theta, which is 15 degrees, okay, times 2 times pi times my radius, which is 7, all divided by 360 degrees. Okay, if I do 15 times 2, which is 30 times 7, so 15 times 2 times 7 is going to be 210. So my arc length is 210 times pi divided by 360. So I'm going to take this number, 210, I'm going to multiply it by pi, and then I'm going to divide it by 360 degrees, and that's going to give me an approximate value of 1.83, okay, and that's units. All right, so that's all we're finding. We're just finding these lengths on parts of a circle, okay? Let's move on to the next page. So a radian measure is another way for us to measure angles. So a radian measure, what I like to think about is kind of a way to show angles, a way to measure angles. Let's do that. A way to measure angles using arc length. Okay. And it took me a long time to figure that out. But basically what we're going to do is we're going to kind of show how an angle measure and an arc length are related. Okay, so we have this thing called a radian measure, and it says that 1 radian is the measure of a central angle. Okay, so it's when theta, whose arc length is the same as the radius of the circle. So 1 radian, okay, means that that's when your arc length s is equal to your radius. Okay, and so and we measure that in theta. Okay, but it's really an arc length. Okay, kind of weird. Okay, but let me kind of talk about how we relate radians to degrees. Okay, so what I like to think about is circumference. Okay. And let's think about this. Let's say that our radius here is equal to 1. Okay, our radius is equal to 1. My circumference is equal to 2 times pi times your radius. Well, if your radius is 1, your circumference is 2 times pi times 1. So your circumference is 2 pi. Now what I do is I call my circumference, this is the same thing. So let's do this. Let's talk about radians. And then let's talk about degrees. Okay? So if I have what I call 2 pi radians, okay, and all that is my distance around the circle. So 2 pi radians, okay, and let's color that in red. I'm going to do 2 pi radians. That is the entire length here, okay, and this is 2 pi radians, all right? Now, if I were to correlate this with degrees, then I would say that 2 pi radians is equivalent to me saying 360 degrees, okay? So that's 360 degrees. Now, if I were to say take each of these and divide them by 2, okay, and cut those in half, if I cut 360 degrees in half, then that's going to give me and let me do this here in a different color, an angle measure of pi. Well, first of all, let's do this. Let's do it in degrees first. This is going to give me 180 degrees. And we know what that is, okay, if we cut that in half, okay, and this is going to be 180 degrees, okay. Then what I can do is I can say, well, if I take 2 pi and divide those out, then that means that I'm going to get pi radians out of that. So pi radians and 180 degrees represent the same thing, okay? And I can keep kind of doing that, all right? If I divide 180 by 2, then that means that I'm going to get a 90-degree angle, okay? If I take pi and divide it by 2, so I'm going to put that as a 90-degree angle. If I take pi and divide it by 2, then that's going to give me pi over 2 radians, okay? And so we can measure these different angles either in degrees, which we are very familiar with, or we can measure them in what we call a radian measure, okay? And we're just going to kind of touch on this. We're not going to go very far with it, but I do want to introduce it, okay? So now, finding measures of, find the number of radians in 1/4 of a circle or 2/3 of a circle. So if I come over here, we've already kind of done that. If I take 1/4 of a circle, okay, that's going to give me a right angle here, okay, and I know that this is 90 degrees, okay. Now what I think about is I think of 180 degrees is the same thing as saying pi radians. So here's degrees, okay, here's radians, okay. Now, it's easy for us to do it intuitively on 1/4 of a circle. It gets harder when we have like other measures like this. Okay, so what I've got is I've got 90 degrees. I know that pi is equal to 180 degrees. Okay, pi radians is 180 degrees. If I take 180 and divide it by 2, and we've already kind of done this, all right, and divide pi by 2, that means that 90 degrees is going to be the same thing as pi over 2 radians. Okay, so this arc length here in radians is going to be pi over 2, okay? And that's what we call it, okay? Pi over 2 radians, all right? So what about 2/3 of a circle, okay? So let's use what we already know about degrees and radians. And let's think about the degree is 360 degrees, and my radian is 2 pi radians, okay? And these are interchangeable. All right, so if I wanted to find 2/3 of this circle, okay, I'm going to take 2/3 times 360. All right, so I'm going to do 2/3 times 360 degrees, and that's like the same thing as me doing 2/3 times 2 pi radians. Okay, so 2/3 of 360 degrees. So I'm going to take 360. Okay, I'm going to multiply it by 2, and then I'm going to divide by 3. And that's going to give me 240 degrees, okay, which is going to be over here. Okay, this angle measure here is 240 degrees. Okay, and if I do that over here with radians, okay, this is over 1. If I do 2 times 2, that's going to give me 4 times pi. Okay, so 240 degrees gives me 4 times pi over 3 radians, okay? So now there's also another way to do this, okay? We're going to kind of talk about that here in a second. But let's look at this last problem here. And what we know is that, you know, if we think about arc length when the radius is 1, we're going to kind of look at that. So when the radius is 1, all right, what do we know about the arc length? Okay. Now, what we have here is this angle theta here is a measure in radians. So theta in radians. Okay, and then we have our arc length in s. So s is equal to our arc length. Arc length. Okay, so now what I know is that if theta, okay, I want to figure out what the relationship between theta and our arc length is when our radius is 1. Okay, and so what I know, and that's kind of why I did that problem up there before, is that if and let's plug in 1 for r. So theta over 2 pi is equal to s over 2 times pi times our radius, which is 1. So 2 times pi times 1 is just going to give me 2 pi. So I get theta over 2 pi is equal to our arc length s over 2 pi. Okay, now if I have the same denominator here, I can set my numerators equal to each other. Okay, so my arc length s is equal to theta when your radius is equal to 1, okay, which is pretty cool. And so that's why we use a radius of 1 typically when we talk about, you know, discussing what radians are and all that kind of stuff. So let's explore just a little bit further what this means here. Okay, now what I know is that my arc length s, okay, so what can we conclude from this? My arc length s is equal to theta when my radius is 1. So we actually have this formula where my arc length s is equal to theta times your radius. Okay, and if so this is what we'll solve for arc length. This is the formula for arc length. Arc length when theta is in radians. Okay, and so this is really important that we have this written down. Okay, now if I take that and I wanted to figure out what theta was, okay, if I divide both sides by my radius, I can get theta in radians if I know my arc length s and my radius r. Okay. And so let's kind of look at the next page and let's use those to figure that out. Okay, so on this one, I want to find arc length with a central angle measure measured in radians. So let's recap. I know that my arc length s is equal to theta times my radius. Okay, I can also figure out my my angle measure in radians by taking my arc length and dividing it by my radius. Okay, so these are two muy importante formulas that we need to use. Okay, so it says in circle O, okay, theta is equal to 2.6 radians. Okay, now let's kind of think about that for a second. Remember when 180 degrees in degrees was the same thing as pi radians? Well, if I think of the number pi, okay, that's 3.14159 radians. Okay, so 180 degrees is equal to 3.14159 radians. Okay, and so radians is a number. Okay, and we use that length to talk about that. So maybe that might have cleared up what exactly a radian is. Okay, we measure an angle in an arc length. Okay, so we have this angle here, theta, that's 2.6 radians. Okay, and we want to know what is the length of the minor arc DE. Okay, so what I know is that theta is equal to 2.6 radians. Okay, and we're trying to find the length of S, this arc length, from D to E. Okay, I also know that my radius is equal to 12 centimeters. So I'm going to use my formula over here to help me out with that. So my arc length S is equal to theta, which is 2.6 radians, and then we're going to multiply that by my radius, which is 12 centimeters. Okay? And so I can figure out what my arc length S is by taking 12 and multiplying it by 2.6. Okay, and that's going to give me 31.2 31.2 centimeters. Okay, and that's the arc length along that circle. Okay, let's move on to the next one. So finding the arc length using radians. So in circle O, in this one, AOB has a measure of pi over 4 radians. Okay. We want to know what is the length of arc AB. So, same thing. I'm still going to use S is equal to theta times R. Okay, so my arc length S, which is this length here from A to B, okay, is S, is equal to our angle measure in radians, which is pi over 4 radians, okay, times our radius, which is 16 inches. Okay, so if I take 16 and divide it by 4, okay, this is going to be 4. So this is going to simplify to 4 over 1. Let me do that. So I'm going to do 4 over 1. Okay, so my arc length S is going to be equal to pi times 4. All right, so if I take 4 and multiply it by pi, that's going to give me a value of approximately 12.57 inches. Okay, so it is kind of, you know, guys, this stuff is pretty heavy on, like, okay, some new vocab, like what's a radian, you know, arc length. A lot of those things are pretty new to you, but again, it's all just kind of plugging things into a formula. So if you need to rewatch this video to really understand what arc length and what a radian is, then please, 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 please do so. You guys doing a great job. We'll see you in a bit. Thanks. Bye.